Here's a guide to understanding electrical abbreviations and index codes. This information is helpful for anyone working with electrical systems or studying electrical codes. Let's start with some common abbreviations found in electrical work. EXA stands for aluminum conductor steel reinforced. The index code associated with this abbreviation is 3.14. AXA also stands for aluminum conductor steel reinforced, with an index code of 3.14. AWG is short for American wire gauge, and its index code is 3.14. Busway is a defined term with an index code of 1.14. Conduit is another defined term with the index code 1.14. EMT stands for electric metallic tubing with an index code of 1.14. Fixture wire is a defined term with index code 1.14. FBN represents fine print note, and its index code is 1.14. FRAL stands for field rated aluminum cable, indexed as 3.14. GFCI is ground fault circuit interrupter, and its index code is 1.14. GND is grounding conductor, with an index code of 1.14. ICE stands for Insulated Cable Engineers Association, and its index code is 3.14. J-box is junction box, indexed as 1.14. JIC is also junction box, indexed at 1.14. MC cable stands for metal clad cable with an index code of 1.14. And GF represents mineral insulated metal sheath cable with an index code of 3.14. NM is non-metallic cable, and its index code is 1.14. NMD is non-metallic sheath cable, indexed as 1.14. NMB also represents non-metallic sheath cable with an index code of 1.14. Raceway is a defined term with an index code of 1.14. RCU stands for Receptacle Cover Unit, and its index code is 1.14. RMC represents rigid metal conduit, indexed at 1.14. SI is shielded cable installation with an index code of 1.14. SCC is shielded electrical cable, index is 3.14. THHN is thermoplastic high heat resistant nylon coated, and its index code is 3.14. THW represents thermoplastic heat and water resistant, index is 3.14. XHHW stands for cross-linked heat and water resistant, and its index code is 3.14. Now let's go through the abbreviations again without the index codes. EXA is aluminum conductor steel reinforced. AWG is American wire gauge. EMT is electric metallic tubing. FPN is fine print note. FRAL is field rated aluminum cable. GFCI is ground fault circuit interrupter. GND is grounding conductor. J-box is junction box. JIC is junction box. NC cable is metal clad cable. NGF is mineral insulated metal sheath cable. NM is non-metallic cable. NMD is non-metallic sheath cable. NMB is non-metallic sheath cable. RCU is receptacle cover unit. RMC is rigid metal conduit. SI is shielded cable installation. SCC is shielded electrical cable. THHN is thermoplastic high heat resistant nylon coated. THW is thermoplastic heat and water resistant. Finally, XHHW is cross-linked heat and water resistant. These abbreviations are used throughout the electrical industry to save time and space when referring to specific types of conductors, cables, and equipment. Understanding these abbreviations can significantly improve your ability to read and interpret electrical plans, specifications, and codes. Knowing the index codes associated with these terms is also important. These codes typically refer to sections within the relevant electrical code book, such as the National Electrical Code, or NEC. These codes help electricians and inspectors quickly locate the specific requirements and regulations related to each item. For instance, if you see MC cable 1.14, it means you can find the definition and requirements for metal-clad cable in section 1.14 of the code book. Understanding how to use these index codes can save you a lot of time and effort when you need to look up specific information. Remember that electrical work can be dangerous, and it's important to always follow all applicable codes and regulations. If you're not sure about something, it's always best to consult with a qualified electrician. Using the correct types of cables and conductors for each application is critical to ensuring the safety and reliability of electrical systems. For example, NM cable is commonly used for residential wiring, while MC cable is often used in commercial buildings or in situations where greater protection is needed. GFCIs are essential for protecting people from electric shock in areas where water is present, such as bathrooms and kitchens. By understanding these abbreviations and index codes, you can improve your knowledge of electrical systems and work more safely and effectively. Always refer to the latest edition of the electrical code for the most up-to-date information and requirements. Make sure you are aware of the latest standards and regulations. Electrical codes are updated regularly to reflect new technologies and safety practices. Regularly reviewing these updates will help you stay informed and ensure that your work is compliant with current standards. If you're pursuing a career in the electrical field, consider obtaining certifications from recognized organizations. Certifications demonstrate your knowledge and skills and can improve your career prospects. Several organizations offer certifications for electricians, such as the National Electrical Contractors Association and the International Brotherhood of Electrical Workers. Participating in continuing education courses can also help you stay up to date with the latest advancements in electrical technology. Many community colleges and trade schools offer courses on topics such as renewable energy, smart home technology, and industrial automation. These courses can provide you with valuable skills and knowledge that can enhance your career. When working with electrical systems, always use the proper tools and equipment. Using the wrong tools can be dangerous and can damage the equipment you're working on. Make sure your tools are in good condition and that you know how to use them safely. Always wear appropriate personal protective equipment, such as safety glasses, gloves, and insulated boots. This equipment can help protect you from electric shock, burns, and other injuries. Never work on live electrical circuits unless you are properly trained and equipped. If you need to work on a live circuit, use extreme caution and follow all safety procedures. It's always best to de-energize a circuit whenever possible before starting work. Before starting any electrical work, always inspect the work area for hazards. Look for potential sources of water, exposed wiring, and other dangers. Take steps to eliminate or mitigate these hazards before starting work. Always follow lockout-tagout procedures when energizing electrical circuits. This involves disconnecting the power source and placing a lock and tag on the disconnect switch to prevent someone from accidentally re-energizing the circuit while you're working on it. If you're working on a project that involves multiple people, communicate clearly with your team members. Make sure everyone understands the scope of the work and the potential hazards involved. Hold regular safety meetings to discuss any concerns and to reinforce safe work practices. Always keep a clean and organized work area. A cluttered work area can be a safety hazard and can make it difficult to find the tools and equipment you need. Clean up any spills or debris immediately to prevent accidents. When working with electrical equipment, always follow the manufacturer's instructions. Read the instructions carefully and make sure you understand them before starting work. If you have any questions, contact the manufacturer for assistance. Never attempt to repair electrical equipment unless you are properly trained and authorized to do so. Electrical equipment can be complex and dangerous, and improper repairs can create a safety hazard. Always report any electrical hazards or safety violations to your supervisor or safety officer. Prompt reporting can help prevent accidents and injuries. If you witness an electrical accident, call for help immediately. Provide first aid to the injured person and wait for emergency personnel to arrive. Never attempt to move an injured person unless they are in immediate danger. Take a course in first aid and cardiopulmonary resuscitation, or CPR. Knowing these skills can help you save a life in the event of an electrical accident. Electrical safety is everyone's responsibility. By following these guidelines and staying informed, you can help create a safe working environment for yourself and others. Now let's delve deeper into specific types of cables and their applications. Non-metallic, or NM, cable is commonly used for interior wiring in dry locations. It consists of 2 or more insulated conductors wrapped in a non-metallic sheathing. NM cable is relatively inexpensive and easy to install, making it a popular choice for residential wiring. However, it is not suitable for use in wet or damp locations or in areas where it may be exposed to physical damage. Metal-clad, or MC, cable consists of insulated conductors enclosed in a flexible metal jacket. MC cable is more durable than NM cable and can be used in a wider range of applications, including commercial buildings, industrial facilities, and hazardous locations. It provides better protection against physical damage and is also more resistant to moisture and chemicals. Rigid metal conduit, or RMC, is a type of metal tubing that is used to protect electrical wiring. RMC is the most durable type of conduit and is typically used in outdoor applications or in areas where the wiring may be exposed to severe physical damage. It is also used in hazardous locations where explosion-proof wiring is required. Electric metallic tubing, or EMT, is a thinner and lighter type of metal conduit. EMT is commonly used in indoor applications where the wiring is not subject to severe physical damage. It is easier to bend and cut than RMC, making it a popular choice for commercial and industrial wiring. Flexible metal conduit, or FMC, is a type of conduit that can be bent easily to accommodate tight spaces or irregular shapes. FMC is often used to connect electrical equipment to junction boxes or to provide a flexible connection between 2 sections of rigid conduit. Understanding the different types of conduits and cables and their appropriate applications is essential for ensuring the safety and reliability of electrical systems. Always consult the electrical code and the manufacturer's instructions to determine the correct type of wiring for each application. Now let's talk about grounding conductors. A grounding conductor is a conductor that connects the electrical system to the earth. The purpose of a grounding conductor is to provide a low resistance path for fault current to flow back to the source. This helps to trip the circuit breaker or fuse and to energize the circuit in the event of a ground fault. A ground fault is a situation where a live conductor comes into contact with a grounded surface, such as a metal enclosure or a water pipe. Ground faults can be dangerous and can cause electric shock or fire. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electric shock in the event of a ground fault. GFCIs work by monitoring the current flowing in the circuit and quickly interrupting the power if a ground fault is detected. GFCIs are required in areas where water is present, such as bathrooms, kitchens, and outdoor locations. Understanding the importance of grounding and ground fault protection is critical for ensuring electrical safety. Always make sure that your electrical system is properly grounded and that GFCIs are installed in the appropriate locations. Remember that electrical work can be dangerous, and it's important to always follow all applicable codes and regulations. If you're not sure about something, it's always best to consult with a qualified electrician. Finally, keep in mind the importance of ongoing learning and professional development in the electrical field. Technology is constantly evolving, and new codes and regulations are frequently introduced. Staying up to date with the latest advancements and best practices is essential for providing safe and reliable electrical services. Consider joining professional organizations, attending industry conferences, and participating in continuing education courses to expand your knowledge and skills.